Hey guys, Mr. Revo here, getting ready to talk about law of cosines. Before we get going with that though, I do want to talk about one quick definition, and that is of what an oblique triangle is. For all intensive purposes, whenever you see an oblique triangle, we are talking about a non-right triangle. Okay, if it's a right triangle, we can obviously use SOHCAHTOA, works great. But if it's not a right triangle, that's where we have issues, and that's where law of cosines comes in, and also law of sines when we get to that. So here is the three ways of writing law of cosines, and just realize they are basically the same thing. We're just naming, we're just changing the letters around. So if you notice, we have c squared equals a squared plus b squared minus 2ab cosine of c. Thing to note is this angle is the one that is across from this side. And that's true for the other two forms of this as well. So you really only need to know one. The other two, you just switch the letters around. Okay. So let me erase that. And remember, the big thing to realize is that lowercase letters are sides, and then the uppercase letters are the angles. Okay. The other thing to also realize is that the side is opposite their angle. So side A is opposite angle A. Side B is opposite angle B, and side C is opposite C. And you can see that here. So there's two times when we can use law of cosines, and one of them is when we are given a side, an angle, and a side. So we are in here, and we can use this to find the side across from the angle. So let's go ahead and do that. So we're just going to use the one that has c squared in it, because that's what we're looking for, equals a. Lowercase a is going to be 190, so it's 190 squared, plus b squared, which is 100 squared. Nice thing is right there, you probably realize, hey, that sounds like the Pythagorean theorem, and it is, but then we have to make the adjustment here for it not being a right triangle, so minus 2ab cosine of angle C. Okay, so that was just me substituting in the values we have here right into this first equation, or this first formula for law of cosines. Okay, at this point, we're going to go to our calculator, type this whole thing in, and we're going to type it all in one step. Okay, and then the other thing we're also going to do is we're also going to square root both sides. Okay, now for this, yes, we are square rooting, so usually we put the plus or minus in front, but because we're just going to talk about a distance here, we're going to keep it positive. So the rest of this is just going right to the calculator and typing in exactly what you see and hitting enter. So don't try to do things separately. This is much easier to just type it all in at once, hit enter, get your answer of 229.6. Okay. Your calculator knows order of operations, so if you just type the square root of this whole thing, you'll get your answer. Don't try to break it up. That's where I see most mistakes happen. Alright, so at this point, we now know in this triangle that this side is now equal to 229.6. Okay, so now the next part is finding this angle. Now, depending on how comfortable or how much you know, You might be able to go to law of sines now, and that'd be a little quicker, but I do want to show you that you can also use law of cosines to find an angle. So let's go ahead and do that. So here, we're looking for angle A. So we're going to use the one that has cosine of A at the end. Okay, so we're going to do A squared. So A was 190 equals the 229.6 squared for C, and then B was 100, and then minus 2 times 229.6 times 100. Okay, so now with this one, you have to be careful when you're solving this, because this term on the right here, this guy, has a variable. Okay, so you cannot combine this whole thing. Okay, they're not like terms. So what we're going to do is we're going to figure out what 190 squared is. Once again, going right to the calculator. 190 squared is, and I guess I could have done that without it, but we're going to do it because I've got it. 36,100. Then we're going to do the 229.6 squared. And while I do that, I can also add the 100 squared to it. Okay, because there's no variable involved there. So 62,007. Ooh, that was ugly. Let's try that again. 62,716.16 minus, and I'm going to do the 2 times 229.6 times 100, and that I'm going to get 45,920, and we still have it multiplied by the cosine of A. Alright, so at this point we have still a variable over here, so you just use your solving rules, your solving process, if you will. You need to isolate the A, so get the thing that's being added or subtracted to it first. Get rid of it, I should say. So we're subtracting that over. Okay, and let's go ahead and subtract that. 36,100 minus 62,716.16. We get negative 26616.16. Okay. Equals, and we have this left over. So then last, well not last, there's 2 steps left. Now we're going to divide by the negative 45,920. Okay, and we keep pulling this down. Okay, and once again we're going right to the calculator. 920. So we get 0.5796 equals cosine of A. Now we're still solving for A though, so to do that we now do the inverse cosine of both sides. So I'm going to throw it in over here. Those cancel, we're left with A. Inverse cosine, going right to the calculator again, and I get that angle A is roughly 54.6 degrees. Okay. So once again, once you learn it, you can do law of sines at this point, but we could have also done law of cosines. It just involves a little bit more work than law of sines would, but it's still good. I don't think you noticed because I didn't mention it, but we were able to use law of cosines here when we had all 3 sides. So the 2 times you can use these formulas is when you have side angle side, as we saw in the first example, and then side 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 also works for law of cosines when you're looking for an angle. Okay, So hopefully you enjoyed the video. Have a good one.